I'm going to talk about dinosaurs again for you, but in a different sense than people normally talk about dinosaurs, also to apologize to Andreas who think that. And I'm going to talk about the lizard hip. And what you see here is a picture of a brontosaur, and she's actually defending her young against something, I don't know what that is, and it's to make sure her genes are being sort of continued. And she didn't become so big for nothing. She became so big and so impressive because of this. It was the hip arrangement. You can see it very well in this picture. The dinosaurs got so big because they had one enormous evolutionary advantage. And when they started, they weren't so big. They were small, but the fact that they could actually move their legs forward rather than sideways, as reptiles do, provided them with a chance to grow in evolution. That is known in paleontology as the advantage of the lizard hip. We still got it, by the way. But we are not so big anymore. They were big because they lived in a niche, a very, very comfortable niche for dinosaurs. They could eat lots of leaves. And it ended sort of at the end of the Jurassic, when Argentina had dinosaurs of about 40 meters. Just imagine 40 meters of animal eating about 2,000 kilos of leaves a day, and I wouldn't want to imagine what they left behind. So very large animals, very large creatures being produced on a fairly simple evolutionary advantage. And this was a reason for us, and this was actually an idea of Koos Burggraaf 10 years ago, to organize our first dinosaur conference. And of course, we drew the analogy with the pharmaceutical industry. What was the evolutionary advantage that allowed this industry to become so big? And the first conference was in the just down the road, in Industrialised, the Natural History Museum, and we invited fairly famous people and people who we thought would become famous in future. So the famous people were Paul Janssen, the founder of Janssen Pharmaceutical, very famous man, almost Nobel Prize. Jim Black, who I got quite friendly with, and I got to know and welcome. Jim, the inventor of the beta blockers and cimetidine, Nobel Prize for medicine. And some other people, and I'll show you some of the things, and I think it's relevant for today to show you some of the things they said at the meeting. You'll be able to read up on all this later, because we're going to give you something that allows you to see it again, so don't run it. This is it. This was Lagosuchus. It's a very small animal. It was the first dinosaur, right? It's about this size. It's not a very big thing, but it had for the first time this hip, and that was the invention. It's the invention that produced all these huge animals we sort of secretly admire. And so it was watching over these people having this discussion about the pharmaceutical industry, and I hope you get the analogies. This is one of them, Steve Arlington, still working in PricewaterhouseCoopers as a consultant for the pharmaceutical industry. And Steve said this. This was just in the time when there was discussion about the AIDS drugs in Africa. He says the industry is a pariah. It has been starved of the brightest brains and the best talents of our medical schools. And he also says, I don't think it deserves that, because it's a really marvelous industry. So what's going on? Here's somebody slightly younger than today. It's Andreas. You just saw him. And Andreas was there. We were actually right, obviously. We were right in... I go a bit further away from that microphone because it resonates. We were right in predicting his career, because it wasn't there yet. But he's already complaining about the fact, he did it today again, but he said, there are too many consultants, and we need new business models, and we can perhaps produce better creativity in smaller units, and it happened. Here's Jim Black, and Jim complained, among other things, is about impatience, right? The long lines of disease study that have to happen before you can actually find a drug, and the long lines of physiological research. So they went for numbers and rather than for content. Don Stansky, an anesthesiologist from Stanford and now high up in the modeling at Novartis, and again, Don predicted very correctly the multidisciplinarity that had to happen in the field. He says you have to link biologists with engineers and statisticians. And actually, no one in universities have actually been trained to get together at these sort of cross-functional disciplines. So we don't do that. We don't train. And so if we don't do that, we have to, because otherwise we can't deal with the innovation, and we have to create new working environments. Because if we don't develop drugs. And finally, Paul Janssen, in that meeting was extremely critical of the pharmaceutical industry, and I left out some of the more outspoken critique. But you know, we spent 2 years on developing a drug, and there was thalidomide, and then America had to be protected against the evil of drugs, so the government started to have a go at the pharmaceutical risks. And he says, you know, that's all the consequence of over-regulation. So what this group, and we found it shocking at the time, it's a group of people who made their careers in the pharmaceutical industry, who lived in the pharmaceutical industry, and when you put them around the table, you put a couple of skeletons of dinosaurs around them, these are the sort of things they say. So what they describe, and I still is an industry that's overregulated, it's unpopular, it doesn't produce much, it's very expensive, there's not much to be gained from managerial, you know, the integration of knowledge, and this comes out of the rest of the discussion, is quite low. People are impatient, mergers don't work, and importantly, the other side, you know, the universities don't actually teach the right skills to deal with all this. So it's a disconcerting sort of outcome of something that 10 years ago there was supposed to be a party. Although we had quite a lot of fun. So the question is, and I'm going to take you through a short analysis of how I think this could hang together. Because we said many of these things, but how does it sort of link? And I tried to use the analogy of the dinosaur, right? I don't say the industry is the dinosaur ready to die, but I just say, what is the evolutionary advantage that brought it to this great size? And I think once you start looking at that, you may actually get to the point that you start to understand, at least I understand it a bit better. This is how the scheme looks. Let's go in there. The pharmaceutical industry is inherently chemical. It was a chemical industry. It started as a dye industry, coloring for clothes, and then it turned into sulfonamides. So it was good at making molecules. And that was, I think, part of this lizard hip of its advantage. No one could do that so well as the pharmaceutical industry. But in the 90s, something came into that. It's an ability, a niche, that allowed the industry to sell drugs at a very high price. That wasn't the case when I worked at Wellcome in the pharmaceutical industry in the 80s. It started sort of in the 90s. A company found a copy, a chemical modification of cimetidine, the drug Jim Black found, and actually turned that into a blockbuster. And they just did it by selling it in the United States at a very high price. And it sort of transpired that people would pay that price. And I don't blame anyone. I personally would do the same if you can ask a very high price and people pay for it, do it. Now, if you multiply the two, you get what is now known as a blockbuster. Sort of military name, Big Bomb was a blockbuster, and you know it was the thing of the 90s. People had to produce blockbusters, things that sold perhaps drugs that weren't too innovative at a very high price. And that worked. It worked because at the same time there were things like the cholesterol-lowering agents who were actually applied to a very large population. They were fairly easy modifiable, and you got a new one and you earned even more. It's quite strange because all other products didn't behave that way. Of course, you got a counter-reaction. The scientific reputation, which is very high in the pharmaceutical industry, when I was there, deteriorated because the prices were so high. This is all chicken and egg, right? So you may turn my arguments around. But because the prices were so high, universities started to ask increasing amounts of money for the trials they did, for the research, because, you know, a rich industry. When I did the large cardiovascular trials in the 80s, we paid nothing for trials. And that actually, I think, also impaired the recruitment of talent. The pharmaceutical industry was particularly unpopular among students as a career. So that, I think, was a counterbalancing argument. What, of course, immediately developed were the access problems Laura talked about, because the drugs were so expensive. Developing world, the HIV field. But actually, it extended over time to the developed world. And when I go to a clinic meeting every week in nephrology, we do worry about the price of some of the very expensive drugs we have to give to the patients and that do work. So the access problem developed because of the price. It also impaired the social reputation of the industry, which again was unfair. Now, because the drugs were so expensive, once they came off patent, it became easy to sell them at a low price, and this generated the generics industry. Generics industry only developed after the 90s when the drugs became so expensive. So it was a sort of self-fulfilling prophecy, and it shortened the commercial life because the pharmaceutical industry didn't want to lower its prices. It's actually quite interesting because any supermarket would do that. Once it came off patent, it would lower its prices. And, of course, governments got on top of this. You see, as soon as the cimetidine, the ranitidine became very expensive, you see in the Netherlands a political and governmental development where people start to say, well, hang on, this is much too expensive, right? It's sort of also led to risk aversion. If something's very expensive, you just don't want it to produce any risks. And finally, it's an increase in regulation, more rules, because you don't want to get a drug on the market when it's not absolutely safe. The industry, of course, could initially respond to that by incremental chemical innovation. Just produce another. They don't do that now, but at the time it was the logical thing to do. You produce another cholesterol-lowering agent. That's been done. There were 5 or 10 ACE inhibitors. But this became less interesting to clinicians. It's obviously the excitement of a new drug and the excitement to do trials and research on a new drug is much greater than when it's one you know the mechanism of already and it just has to be done. So, and I saw that happening in the time when I was still doing large clinical trials. You got this competition for patients. And not enough patients to do all these trials. So you start to pay more for them. A market in patients develop because people are mad. You know, I have my 20 heart attack patients and you get them for £1,000 per patient or something. And this makes the development time higher because all this hangs together, right? It becomes less interesting, it becomes more expensive, and the whole of the field rises. I'm not saying that's the only reason, but it is something that really happened in the field. Now, that's a nasty sort of mix. It started with good news, and it ended with sort of lots of things going against it. Initially, it was thought that the only way to deal with that is get bigger. And you see endless publications in the 90s where, again, management consultants, but also companies, they explain that, you know, if you get bigger, you get more market share, and if you have more market share, we learned that in business school, you get more profit. And in fact, in our own dinosaur meeting, there's somebody who says, 10 years ago, he says, you know, in about 10 years, so today, there will be 5 companies left. And they will all have 20% market share. That's how it's going to go. It's inevitable. Well, don't predict, I'd say. But this was the going thing. So people merged and acquired. And at the same time produced marketing efforts and tried to exert political pressure to keep the prices up. that is a response that actually has been going on till today, and I think is not an important reason that we're stuck with this, what I call a big paradox. It's a paradox of a group of companies that never produce pollution, they never they treat their employees almost exemplary, they produce actually drugs that there's evidence that medicines in general have add about months a year on life expectancy. It's something people actually really, that it helps people, and Andreas showed some examples. And why is this industry so immensely unpopular, and why are we stuck with companies that are actually producing much less value, and they actually treat their employees in China very badly, and they're immensely popular? I find that still something difficult, but I think it is part of this problem. It's part of this analysis. So the dinosaurs, at least that's the going theory. There was this meteor which hit Yucatan in Mexico, and all this bad weather that went on, and all the leaves fell from the trees, and it wasn't such a good time to be very big. It was not a very good time to be cold-blooded, and well, you end up in the museum here in Leiden, and little children come and watch you. So when your niche changes, that's a big problem, and it suddenly happens. It can suddenly happen. So the meteor of the dinosaurs who had this lizard hip, and this was really good, and they could grow, become very big. What is the meteor for the pharmaceutical industry? What is going to hit it? And some people would say, well, actually what hits it is the fact that somebody is going to reduce prices. I don't think so. I think what the meteor is that's going to hit the pharmaceutical industry is this. This is the result of a system. It's called systems biology markup language. It allows you to put all the knowledge about a certain disease in a model. This is the model for Alzheimer. Japanese researchers have done this. They went through all of the knowledge and put it together, trying to find out how the biology of Alzheimer hangs together. I'm not going to take you all the way through, but it's frightening if you think about it, if you just zoom in on it a little. This is just a little part of what's going on in the neurons at Alzheimer. There's about 6 or 7 MAP kinases, certain things that are involved in cell growth. You could actually, and Andreas pointed it out very nicely, you could actually inhibit all those. You can give antisense drugs, you can produce monoclonal antibodies, and you can knock one of these out. But just think about how many there are, and is this going to actually, this is a model of a cell with somebody with Alzheimer, but is it actually going to, in the end, after you've done all this work, allow people to remember the names of their children, or be cared for better, or have a real clinical outcome? Well, you don't know. And if you're wrong, you spend 1.5 billion euros on developing it, and you may not even need one of these things, you may need several. And I think this is a huge problem, and it's a problem that's not the problem of the pharmaceutical industry, it's a problem of all of us, because we need good new drugs for the diseases we have. Now, the approach we've seen up till now has been, I think, largely monodimensional, and I'm against monodimensional solutions. If you have a very complicated system and you start to just take care of one of the components of the system, normally nothing happens. The rest of the components adapt themselves. So I'm going to take you through some of these solutions. The one was size, remember? People said, if we become big, we become powerful, and we can do much more effective research, and we can sell much more effectively, and in the end it'll all be all right. So, well, actually, there's quite nice evidence from somebody from Lilly who sorted this all out in a paper in Nature Drug Development. Just look at the productivity of 3 of the really big, important companies. And it is, if you start in 1950, it's surprisingly linear. They just keep producing the same sort of drugs on a larger scale per year. although they grow. It's quite interesting. I mean, occasionally there are these sort of flat areas. This is, of course, where it's before Andreas joined Roche, but would be a moment to call in the management consultants and say, our productivity is flat. And they come in and they do something and there it goes. It just shows that this is not a very stable thing, but over the long run it is very stable. So I thought this was a really good graph. What he also showed is if you take Lilly, who didn't get involved in mergers, this is their line. And if you look at some of the companies that heavily got involved in merging and acquiring and changing, this is their lines. Now, it could be coincidental, but it is interesting that it appears to affect, and it's something most of us who've dealt with this seem to recognize, it seems to affect their speed of innovation. What he also showed, and what was even more interesting, is that if you look at the number of companies in the world, here they go up, and this is sort of around the 2000, this is where the common thought was, we need to have less, right? We have too many companies, it's too small, it's too fragmented, let's merge. So they go down. And this is the number of drugs coming out. I think this is probably an outlier, but even so, there is a rather disconcerting link between the number of companies and the number of drugs. It's not unreasonable because innovation happens in funny ways, and if you just try to innovate in one place, you don't get just as much. But it's quite clear that, and here's a link between the number of companies and the expected output. And in fact, in the world, there's much to be said to have more companies than less. I think that is now known, but it was tried, and the result of this was what we see now is that there's a decrease in the number of drugs that go in the world that come from big companies and an increase from small companies. But of course, that comes with a problem. The problem is that the rate at which these small companies put out new drugs, divided over the number, there are about 5,000 of them in the world, and only 50 or 75 big pharma companies, is very low. So you get an enormous rate of death of these small companies. It's an evolutionary system probably, but this goes at the expense of quite a lot of shareholder money that actually disappears. But there is an increase in this rate, and it's interesting to see how it will go. So that didn't really work. And actually nothing worked, because if you look at the output, and this is a long-term, starts in 1971, of drugs going on the market in England, it's surprisingly flat. So that does produce a problem, because on the other hand, on the other side are all these inventions and all this biological knowledge that drives, and it seems to go through a very, very thin funnel. And the cost, of course, of that is enormous. Reduction of regulation is being often quoted. If we get rid of rules, the whole thing will loosen up and we're okay. There are too many rules. It's something you read all the time. Well, actually, the attention going into that is something Marcel Kenter and I described in the Lancet last year about an initiative that goes on in Europe to speed up the approval of drug trials. And it's a law that starts with, I think, about 70 considerations only before you get to the text of the law, and it has a level of complication that gives a normal person quite severe palpitations. So what we said is, there's no point in changing the rules. Let's not make them easier, because actually this whole thing covers the wrong field. We're actually trying to fix the roof of something that doesn't work. Because do we need new rules for drug trials? Actually, we don't. Healthcare is going to be a mix of studies in surgery, studies of nutrition, studies of devices, machines that help us getting healthier, and combinations of those with drugs. And in fact, the rules don't cater for that. We are going to spend the next 3 years in Europe discussing new rule system for something that's actually a rearguard action. And what is a real problem in Europe is, and you may not be able to see it, but there's a huge diversity in research capacity. There are countries like the Czech Republic who have 109 ethics committees, but put out about 1/5 of the research output of the top countries. I put them at the bottom in this table, but the top countries, Denmark and the Netherlands in Europe, and they have a totally different level still throughout the country of knowledge. So maybe we should do more about the knowledge in these countries than actually getting their rules together. And in fact, if you look at the whole problem of rules, we once demonstrated this. One of the things that happen as a result of the rules is that people have to scrutinize data. You have to really be sure the data are right. And for this, monitors fly around the world and they control data and they check them and they put little yellow stickers in to make sure that they're okay. And we once studied 1,500 of these questions, right? This is half an hour work per question. And we said, now, which of the answers would ever have affected the end result of this particular research? And we found about 0.4%, and that wasn't very important as well, but we were fairly strict in our rules. So here's a whole system that actually is unnecessary. The rules don't reinforce it, it's just being considered best practice, and it costs a vast amount of money. So we have to try to see that that also doesn't work. Just get rid of the rules doesn't work. You have to interpret the rules in a way that's sensible, and it's much more important. Marketing, well, Andreas already showed it. It works, but it is also very bad for social reputation of the industry. The last $3 billion fine the Americans gave to a company regarding its false advertisement of drugs for depression hits the news quite badly. And it is also, I think, again, disconcerting if you think about what sort of research in depression, a very distressing disease, could be done with 3 billion euros. It would be a lot easier if we just didn't market but spent the 3 billion on research. But of course, in the way the system is structured, this is entirely correct. Shareholder value is something that was at a certain point considered to be the whole driver for the thing. You know, if we just make the shares go up, then we get more money and the whole thing will work. Well, it has led to, I think, a lot of capital going into this industry, but it's also led to strange situations. Pages are tore out of an annual report of a company, highly scientific company, high level, very, very impressive research, and this is the amount of pages they need to, in the annual report, to describe the salary of the CEO. This is the remuneration report in the annual report. It's 21 pages. And this is what they need for the science. I don't think anyone likes this. This is the point. I don't think there's anyone who would ever say that this is good. But it just happened. It happened because there was shareholder value, and then you got control agencies that you have to make your annual report properly, and we need to know everything. It's strange. And actually, the sort of shareholder value of this company, well, it goes up and down. So if you bought something here and sold it here, you'd be all right. But if you bought it here and you sold it here, you'd be about equal. And it's a good investment because it produces dividends, and you could do worse than having shares in this company. But if you actually look at the comparison with another company, then this is the company I just showed you. This is the pharmaceutical industry. And this, of course, is the one, it goes down, but this is the one that makes all the stuff I carry around. It's named after a form of fruit. And that actually produces computers, right? It produces nice computers, and some of my members of my family would say I'm actually more addicted to this than to drugs. But it is just Apple, and it treats its employees quite badly in China, and it doesn't produce anything people get a lot better on. So why is this appreciation is different? We have to do something about this, and this is the next 10 years what we have to do. Finally, industrialized. There was a time when people thought, this research system is so inefficient, it's all done by scientists and they're inefficient people, so let's just line them up in a good industrial system, sort of production line, and get this research through in no time. Dow wants me to speed up, I can't. You have to pull me off the stage.
You are the boss.
Yeah, it's the... I'm the farmer's daughter. People complained, this was the CRO, right? The CRO started to organize the system. And there's been quite a lot of criticism of this, although if you now look, and this has gone on, that most of the research money that goes into, used to go all in universities and to doctors in universities. Now it's more than 50% goes first to a CRO and then to the doctor in the industry. So this is an attempt to make it more efficient. Actually, the New England Journal, the New England Journal writes something quite scathing about it. So, you know, if you want to continue like this, stop talking about deliverables and billable hours, but could you please also get this money into the discovery of new knowledge? And this is really necessary. It's not necessary to have good systems. This all came to a head in about 2006 when there was a drug called TGN 1412, highly innovative drug, which was put in this outsourcing model. It was outsourced offshore. There was only 5 people in the company. It was highly efficient. And when they gave this drug to 6 young people in London, they all got severely ill, almost died, and some are damaged right up to today. And if we look back, then you can see that the company actually forgot to make some fairly basic scientific calculations about the dose, and they gave a dose of about 100 times too high. And that was all preventable if there was some sort of scientific control over the whole thing. So there are more examples like this. And in fact, Jean-Pierre Garnier, who was the CEO of Novartis, said this. You know, he said, and he'd been part of it. He said, we assumed that it was scalable, that you could industrialize it, and you could drive it by metrics. And the ground result, loss of personal accountability, transparency, and the passion, and I think that's very important, of people in discovery. And I think that also contributed to this whole problem. I'll skip this for now. When we thought about this, what are we doing here, and why it's slightly different from what happens in the rest of the world, I hit on this paper one day at the airport from Michael Porter, and I thought that this shared value concept very much fitted what Douwe thought of, I think, when he established this organization, which we've been trying to do over the years. So I'll give you, and then I'll end, some examples of where we think we produce this sort of shared value in CHDR. And to do that, you have to do what Laura just said, think about the products and the markets in a different way. So research that actually fails drugs, that shows that they don't work, is highly unpopular. You won't always have something that works, so you have to reward that sort of research. The developing areas in the world that are now being used because they have cheap labor, you should use to actually develop the countries, because you then also develop the market there. And education, very important, because if you educate people, they will take up innovation, they will actually use the drugs, and so actually investing in the education is about the cheapest way of getting people to use drugs. Maybe not next year, but maybe in 5 years. Also, I think the R&D, which has now been disintegrated, universities, the only part of this R&D, should be reintegrated, because that teaches people how to work. Local drug production, very important. This now happens in factories in India, and we have regular problems with the fact that the quality isn't right, and then we can't change it. The use of commercial studies that are being paid for people's PhD, and personal development is something. And I think I'm in a committee that looks at the carbon footprint of clinical trials, has to be reduced. People fly much too much around when they do trials. So, and finally, and I'm very pleased the mayor is still here, because he's been one of the important people in getting the Leiden local cluster, a science park that acts locally, and we very much believe in that. But also what I call goal-oriented clusters, people who get together to solve a problem for an industry in an area like the Netherlands, which enables profit-non-profit collaboration. I think the days of all these different companies that compete with each other in this field must be over, otherwise we can't deal with the complexity that hits us in the future. So the prototype development models, and you can read about that in what you're going to get later. This sort of thing, which needs many animal species and humans, and studies in molecules, and studies in cells, and studies in systems, and then finally give it to the whole rat or the whole person, is something that needs a highly integrated sort of science, only really to be found in universities where people are together. It can't be done by email, and it requires the sort of environment which I think was already discussed in the lectures. So quickly through the models, and then I'm through. CHDR, we talked about the dual focus, but what it can do is in fact something like this. If you have a new prototypical sleeping drug, you can, which a company made, and some of the people of the company are here, you can do a very quick study, and you can compare it with the drug on the market. You get something like this. I only was going to show you one graph, I think. And you can see that this is a measure of sleepiness. It's something how you move the speed. We use the speed at which you move your eyes. In fact, something we developed a very, very long time ago in Wellcome, but it's still usable. This is placebo, so you give nothing. Then if you give somebody an existing sleeping drug that's on the market, here it is, you get sleepy for about 3 hours and then you wake up. And this is the new one in a dose of 400 milligrams, so you get sleepy and you wake up after about 7 hours. So quite a good drug, quite a good time profile of its course of action, and it led to a paper in a very good journal by a joint group from the pharmaceutical industry and us. So it's science. It produced also money because the company got payments for this drug. In fact, the drug later on was taken off the market for another risk factor, but it shows that these sort of things are shared value. Another one is education. We have an education system we use for the students, a website, and it's actually used quite a lot. And this is not Mark Zuckerberg, but it is a Leiden second-year medical student, Hans Pinkaars. And Hans called me up one day when he was doing this course, and he said, you have this hopelessly old-fashioned website, and I turned it into an app for my iPad. And I said, so how did you do that? And he was silent for a bit. He said, well, actually, I stole the data off the internet. Do you mind? I said, no, I don't mind. You got a job. And he turned it into an app for the iPhone and the iPad, and look what happened. This is today the downloads in the world of the TRC app Hans made. It's about 25,000. You can see sort of that it also happens in areas like India and Africa and South America, where we can now, without any further effort, teach people how to use drugs. It's free, and it enormously adds to teaching. And this is how shared value happens. It doesn't happen the way you think. And this is the number of downloads. It's about every week about 1,000 people get this piece of teaching from Leiden, and we don't have to do any work at all. And it happens because one student whom we talk to does that. Our PhD program is another one. All these fellows have done work which also benefited industry. Leiden Hospital Pharmacy is another recent example. We've made local drug production at a high level in all sorts of extremely high tech, totally acceptable to the international pharmaceutical industry. And it allows us to actually innovate with new drugs very rapidly. And it's an investment of the government, and it's used for commercial purposes, but also for the care of the patients in our hospital. Finally, data management. To deal with data of trials, we set up this system Promises, and again, you can download later your own application for it. This is Jos Hennen, who's been with us almost since the beginning of CHDR, and Wolf Vondracek at a training session for WHO in Thailand, where the system is being used to do trials with measles vaccines in children in India. So that's again an outcome of something we did here, which has enormous implications. And here, if you go to Seoul National University, where I was 6 weeks ago, you see a Korean, South Korean research assistant using exactly the same data management system as we do in Leiden. So this helps them to do research, and it helps us, and finally you can do this on your iPad in the world. My last example is perhaps the one where I was brought up. It's the ultimate shared value company, Wellcome. Henry Wellcome, the founder of the company, who set up intensely scientific company. And when I was there was John Vane, Nobel Prize winner. There was Jim Black, whom I talked to you about, Nobel Prize winner, and Gertrude Elion and George Hitchens, people who made really drugs that changed the world. And they were all together in one company, and I was allowed to be there for some time. This is me, in case you don't recognize me, doing an experiment. And I'm immensely pleased that Arthur Fowle, who taught me clinical pharmacology and was my boss in Wellcome, and his wife are here today to watch this. And that's also shared value, because of that we got to Wellcome Trust, the biggest funder of research in England, because Henry Wellcome didn't give his shares to his shareholders. He gave his shares to a trust, and they sold them and got an amount of money for research that amounts to about £600 million a year. But it also got this anti-epileptic drug I worked on. It's got us AZT for HIV, and it got us, in many ways, CHDR, because it wouldn't have happened if I hadn't learned at Wellcome what I learned to do here. And I think that was a value that wasn't intended in Wellcome, but I think certainly built in. So I need to be grateful for that. And that brings us to the end of my lecture, and this is where we're now, a meeting place for people who want to do research with drugs. It's not only us, it's going to be people from the outside coming in to do this research. It's collaborations with industry, it's collaborations with other universities. And I think the only way to deal with the complexity meteor that's hitting the field in the next 20 years. So I'm pleased that we reached at least this stage. You could perhaps say that we also need the dinosaurs, because we've now reached the size of a sizable dinosaur. But when I go to our meeting room, I can see a friendly dinosaur. It's actually in one of our meeting rooms. It's a friendly dinosaur, and it's watching over us, and I hope it keeps doing that for some time to go. And I think that's about where we are at the moment. And